bringing you another presentation in our Unimetrics series. Today is Tuesday, April 16th from Chico, California. Yesterday we discovered the importance of having moved the unit number 1 to the circumference of the perfect closed line called the circle. By doing so, we establish the linear metric in circular space on the curved line. Nobody ever thought to do that. It has been done virtually, mathematically, in order to compose sine waves and Fourier transforms, all of which represent circular functions. And already we've discovered the wavelength-frequency relationship that is on the circle and only on the circle, and nobody looks at the frequency-wavelength relationship as a circular function, which it obviously is. That explains so much down the line that it's unreal. How clarifying is that vision of circularity? Because light speed, we discovered yesterday, is the circle. That if you want to picture what light speed is, it's not two parallel lines where you have a metric for the distance, which would be like a light year is a distance measurement, but it has the word year in there because there's another unit of measurement for the event separation. From this atom in the star to this atom in your eye is a double separation. That's called relativity, by the way. Relativity. But the statement of relativity is in linear mathematics. That it is only one way to compare two quantities with linear mathematics. And that's in parallel. In parallel. Why? Because the only way to measure one extent against another extent is, first of all, to linearize whatever quantity it is. Remember that sine wave that goes up and down? And yet you saw the linear separation between the crests. Well, what happens to that curve that's going between the 2 points of measurement? It's not going straight at all. What direction is it going in? It's going in a circle. So what is it? What is it that's going in a circle? We only have one word for that. Frequency. It's a different data type that's not linear. We proved that on the surface of the circle. Let's look at that again. And I have something prepared for us today. This is called Geogebra, and I've given 3 presentations on how to use Geogebra if you're interested. I'm going to switch over to that screen now so I can actually manipulate it. And I'm expanding it now and centering it for us so we have a better view of this. Now here you see an interactive Geogebra program. I'll have links for how you can discover how to make this yourself, or you can actually copy this from my public site. The universe is entirely spherical. We're going to be able to prove that. You don't need to accept that blindly. IP has a value of 1 over 2. OP has a value of 2 over 1. These are 2 component numbers that parameterize the circle. This is called inversive geometry. In the lower right quadrant, you see that there is a sector that's cut off by an arc. And the arc is determined by points A, which I highlight now, and D. A and D. Those are the end points of the arc. And now I'm going to move the point OP because this is an interactive diagram. Now I'm going to move OP towards D and watch the sector made by the arc. Is it getting smaller? Now it's getting smaller more rapidly, and now it's closing. And now, notice the values. IP is now 1. OP is now 1. That's because every so-called point on the surface of the circle has a value of 1. And the reason for that is it has no context, so it doesn't seem to have any meaning. That's true. So why are they both 1 now? It's because the surface value of this circle is 1. All right, so now I'm going to move OP back out. And you see up in the upper right, it's increasing, going past 1 now. And it's approaching 2 as IP is approaching 1/2. This is set to lock, so it did so. I'm right-clicking on the screen, and I'm going to Settings. So I'm just going to click on the screen, and now it shows the settings for the screen. I can turn off the grid. We would prefer to see the grid. And right below that, it says Point Capturing Snap to Grid. Click on the down arrow and turn it off. And now see what happens. Use this little X up here to close this. And now we're going to move OP off of 2 and then move it back. And now it won't go. It doesn't click. It doesn't snap to grid, and I can't get it exactly on 60 degrees. Although this does say it's 1/2 and 2. Watch this. I'm going to zoom by scrolling the mouse so we can get a better view of where OP is actually at. What I did is click drag to recenter it, and now scroll to increase the granularity. We're homing in on OP, and look at that, we missed 2. All right, so we're going to right-click on the screen, click on Settings, re-click on the screen, and now Point Capturing, Snap to Grid. Now close this, and now move it first away from 2, but now get it close to 2, it snaps. And to prove that, we're going to zoom back out, recenter this by click dragging, and now move this off of 2, and now when I move it back towards 2, it snaps. So that's snap to grid. Now up here in the upper left of the screen, look, and you'll see things being highlighted in the toolbar. The second to the last one says A equals 2. Click on that and select ABC text. Now, this is not intuitively obvious that this is a display box for changing values. Normally, text does not change. So this is very poorly named. But if you click on it, it tells you down in the lower left what to do next. Select position, that's for the box. You can't see the pointer, but I'm clicking right below OP equals 2. Now I can put in, and now click on Advanced. Select the second one, that's the Geogebra symbol, and it gives you a list of all your variables. Double click it, and it shows you what I had to type in to make this work. So I'm going to click on Preview, and you see it puts it in complex format. So the output would be OP equals 2 plus 0i, which you could read, but it's kind of a nuisance. Now notice that up here, that OP is, even though it's typed the same, this is an object, whereas this is text. So in order to get the real component out of OP, you click on the object, and it produces this text box. Now you can put in a function. It's lowercase real, and it's telling me check my input because I haven't obtained closure yet. It doesn't know what I'm doing. But now it does. And now it'll show OP equals 2 because it's selecting the real portion of that. So that's a little insight in how to use GeoGebra. Again, this figure is available to you. I'll have links for how you can either copy this and work with it, or you can create it yourself from scratch using a 2-tutorial video sequence that I made just for this purpose. So again, what this is showing us is that the linear numbers that control position on the circle, which how is that done again? By moving OP, it changes the position of A. And as you move OP, A keeps moving towards -1. At infinity, that will reach -1. Now, IP is equal to 1 and OP is equal to 1. That's because they met at the circumference of the circle, which has a value of 1. It's very important to realize that this circle has the value of 1. And if it doesn't make instant sense to you, it's for the same reason that it made no sense to anybody throughout history. So you're learning something that's entirely new in science. As OP moves, this arc changes, and therefore the sector value changes. This arc length is changing because of a linear change. So the linear change is executing a change on the surface of the circle in one of those arc segments we saw earlier, which represents wavelength. Here the frequency is not 2 because these are not equidistant points. The smallest separation of 2 points is on a diameter, and the smallest separation of 3 points, this would be a harmonic separation of points on the surface of the circle, perfect equilateral triangle. This is the translator between linear and circular space. I will say it is one representation of the direct relationship between linear space and circular space. It solves the problem that the Greeks had in relating their linear system to the circle, which they literally could not comprehend. They're directly related. What you're looking at is brand new. Nobody has ever seen this relationship, ever. And it's the most important insight for physics right now. Just this, what you're looking at, because of the relationship of this arc to this length. If I move to 4, then IP is the reciprocal. That's a fixed relationship all along the line, and it's balanced on the circle. IP and OP represent the number 1. Why? Do you know why they represent the number 1? It's because they multiply to 1. The outer number, which changes harmonically with the inner number, they always multiply to 1. And when it reaches right here and they meet, and now they're the same point, there. Now, they're both 1 because any value on the surface of the circle is going to be 1. And that's due to the relationship between IP and OP. That it becomes clear what the relationship is here. They both represent the number 1. But they only represent the number 1 when they're multiplied together. Now here, it's shown that they have the value of 1 each. This one for IP and this one for OP are linear 1. But when these are out here, and they still multiply to 1, even though neither one of the numbers is 1, the entire number is 1. So these two numbers together represent 1. And anywhere you move OP, all the way out here to 4, they still multiply to 1. In other words, IP and OP form the parametric equation of the circle in two-componency form. IP and OP together form one number, a two-component number that parameterizes the circle on the relationship between the two component numbers. They're in a circular relationship that's represented on a line by a split number. IP is one of the numbers in the split, and 2 is the other number. These two numbers are unique when they're put together. So all of the unit fractions, by which I mean 1 over 2, 1 over 3, 1 over 4, 1 over any of the counting numbers, with its reciprocal, which will always be a whole number, those two numbers multiply to 1. And that's the parameterization of the omega circle. I call it the omega circle to distinguish it from the unit circle. You're changing the circumference from tau to 1, and therefore you have to change the radius from 1 to the inverse of tau. That would make the linear length of the radius the length of the radius would then be the reciprocal of tau, which is approximately 0.166. It's irrational because the relationship between linear space and circular space is on a constant irrational. But you can choose which one of the two components of your relationship you wish to have linearity expressed. On the unit circle, we put the linear number in order to get the linearization of the circle, which comes out to tau. But if you declare that the circumference of the circle is 1, then you know the radius. The circumference gets larger, the radius gets larger proportionally. This is the way to get two linear numbers to parameterize the space of the circle. Normally, we do that with sine and cosine, which is a transcendental functional relationship between two curves. That is ineffective, inefficient, and ultimately inappropriate. Because the two numbers, sine and cosine, are irrational. We're going to take a break here, but we'll be right back to continue this because we're getting into something that's both challenging and profound. My job is to make it easy and understandable. That is what I intend to do. We'll be right back. Stay tuned to Anagalactic, so stay tuned. We'll be right back.